CocoaHeads Berlin. This is our first online event. Definitely it's another experience to compare with our offline events, but if you like it, please give us any feedback. If there's interest from you, from the community, we as a CocoaHeads team would be happy to make it on the regular basis. And of course, to organize the events, we need speakers. So if you would like to share some knowledge, please contact with us. Giving the talk online has its own benefits. It's less stressful as you can pre-record your talk, and the audience is much wider to compare with our in-person events. So we are looking forward for your talk proposals. And today we have two great presentations. Dylan Maryk from Door to Door prepared some tips for unit and UI testing, and Mikhail Rakhmanov from Blacklane will share his experience with Redux architecture. And we have Q&A sessions after each talk, so please send your questions to the live chat on YouTube or in our Slack channel for our speakers. So let's start. Enjoy the event.
Dylan. I'm an iOS developer at Door to Door. We work on apps for mobility, transportation, and basically for getting users from A to B. So today I'm going to give an overview of unit and UI testing on the iOS team and how it's improved over the last couple of years, some of the tools we've been using, some of the approaches we've been taking, and we'll dive into a bit of code as well. So we'll start with unit tests. So why were we not writing many tests a couple of years ago? This is very opinionated, but I would say that Apple's test suite offers poor and outdated syntax. They're difficult to write, these tests. They take a long time to write. They're not very readable. And it's an all-around bad developer experience that we get with the default toolset that Apple gives us. It's not enjoyable to write these tests, I would say. And I think that was part of why we weren't writing them. There's a lot of tooling that isn't available, such as, how do we mock things? For example, there's a lot of manual effort required there. So we were not investing as heavily as maybe we should have been in testing. So this is a kind of rough overview of our architecture that we use within our project. MVP Plus is kind of how I'd refer to it. It's a model view presenter, but with some other bits stuck on top. But these are the important components to take note of. So we have all our business logic separate, isolated in our presenters, and then the presenters will communicate with views, so view controllers, and then sometimes other delegates to inform them about things that are going on within the presenter. And then the presenter will have dependencies injected for networking, for example, or like a user manager, so is the user logged in or out, details about the user, and for any other kind of communication with backend or with other data sources. So we want to make sure that all our business logic is kept within the presenter, and that's partly so that it's testable, so that when we're writing tests, we're only testing logic. We don't want to be testing views and how they behave. We don't want to be performing real networking requests to the backend. We don't want to be getting involved with storing data or retrieving data from databases, core data, user defaults, whatever it is. We just want to focus on testing that logic. So part of how we do this is by mocking everything outside the presenter. And that's where we basically want to create fake instances of real classes, and we want to stub their functions. So that means that when functions on those mocked classes being called, real functionality is not being executed. We're replacing that with fake data or even not doing anything. And that's so we can control the input and output for the presenter and reproduce the input and output the same every time we run our tests, so that, again, we're only focusing on testing the business logic and not anything external. So unfortunately, mocking is a lot of effort if you're just using Apple's tools. If you're just building your mocks from scratch, you have to go through a lot of effort to manually recreate classes to make kind of fake versions of them you can then inject as dependencies or set as properties on the presenter, such as a mock view or a mock delegate. So to achieve this, we ended up using a couple of libraries we found and I'm very happy with. So the first two are Quick and Nimble. These two libraries work very closely together. So Quick offers syntax to make very readable tests. It's based on RSpec, which is a popular Ruby library for writing tests. And we'll look at some examples of that a bit later. And Nimble offers readable and feature-rich assertions, make it easy to say, for example, I expect this property to have this value. And again, we'll look at examples of this later. And then we have Cuckoo, which is a great library which allows you to very easily mock dependencies or whatever classes you like. And it does this by subclassing protocols or classes, and will automatically generate mocks of your classes by doing that. And once that's done, you can then verify that these stubbed functions on these mocks are called. So you can verify that your presenter or whatever class you're testing is calling the functions on your mocks. So here's an example of Quick and Nimble. So this is one test where we were testing a mapper, and that it's mapping one model to another. So you say we have this nice syntax: describe route ahead of view model map test, context when the route is walking route. Nice human readable syntax, and that's very much based on RSpec. And then we have some further context when the departure is in less than 15 minutes. And then inside we can have multiple its, which is where we have the test itself. So we're saying, first of all, it returns a route type string for walking. So we're saying that we expect that the model's route type should equal the string walk. And you can see here how nice and easy to read that is. And there are a lot of different matches you could use. So to equal is just one example of what you could do. You could say to not equal, to be nil. You can even do to eventually be. So your test will actually wait a little bit for a value to be true, for something to be equal to a value. So there's a lot of combinations you can use, and you can just dive into the README and get a lot more information there. So onto Cuckoo for mocking our dependencies and stubbing the functions on these mocks. So before suite is where we can put all of our setup for all the tests we want to add below this. So here you can see we're setting up a few mocks. So for example, the first one, configuration holder equals mock configuration holding. So configuration holding is a protocol to which configuration holder conforms. And then we just put mock before that. And at compile time, Cuckoo will create a mock. So it creates a mock of configuration holding and sticks the word mock in front of it. And that's all you need to do to get access to that mock. And then you see we do the same for delegate interactor and view. They're all mocks of protocols. Then we create our planner presenter, and this is a real implementation of planner presenter, not a mock, but we're injecting a mock configuration holder into that as a dependency. And then we're setting delegate interactor and view as mock properties. And then we can stub, for example, our view. That's a mock, so we can stub functions on it, and we can say how these kind of fake functions should behave. So for example, we're saying whenever set polygons is called on the view with any, so with anything being passed into that function, then do nothing. If you look at the last example, expand time bubble, we're saying that whenever expand time bubble is called with a search mode text that is any string, and a date text that is any string, and animated that is any bool, doesn't matter if it's true or false, we're just saying if it's a Boolean, then if that is the case, then do nothing. And there's more you can do than do nothing. You can say, for example, then call real implementation if you want to actually call the real functionality of that function. Or you could do then return. If it's a non-void function, if it actually returns a value, you can say then return this or that. So by using Cuckoo's verify statements, we can check that our stubbed functions on our mocks are being called when we expect them to. So here, for example, we're saying with the context when the time bubble should be expanded, when the selected search mode is arrival, and when the selected date is in the next week. Then before you run any test, we want to do a bit of setup. So we're just creating a couple of dates and then calling plan presenters expand time bubble function. And then we want to check with our it test that expand time bubble is being called on view, but not just that, but that's being called with the parameters we expect. So we expect the search mode text string to be arrive, the date text to be Wednesday at midnight, and that we're saying animated is true. So a few of my top tips for writing unit tests. Separate and test only your business logic. That's all you want to be focused on. Get rid of the view. Don't worry about testing, real backend communication or talking to a database or anything. You just want to be testing that your logic makes sense. Force unwrap. I would say don't worry about null safety in tests. Don't worry about unwrapping properly. Just put exclamation marks everywhere. It's fine. Because if there's a problem there, your tests will fail. It's only going to fail on your local machine or on your CI, and then you can go fix it. It's not a big deal. And let your tests influence your dependency structure. So what I mean by that is, for example, is let tests show you where you can separate your concerns better. So for example, if you're doing a networking call directly in your presenter or whatever your class is that's taking care of your business logic, and then you're running tests on that, you're going to find that you're performing a network call every time you run your unit tests, which you don't want. And that will show you that you should separate that into a different class and have it as a dependency instead, and a dependency that you can mark. So let your tests show you how you can clean up your code and better separate the components in your code base. Okay, so now let's move on to UI tests. So the original problem we had was that while we were now doing more unit testing and we were testing on business logic, and that's great, we didn't have any automated methods still of testing that our core flows going through the app work as we expect from end to end. So a real user journey, can they log in or register? Can they then perform a search for how they can get from A to B? Can they then book a ride? Does this all work from start to finish? And for this, we were relying just on manual testing. So we'll go through the core flow of the app before each release, every couple of weeks. Before we released an update to the app, we would be manually testing that the core functionality still works as we expect it to. So we looked at a couple of libraries for this. One pretty big one is from Google called Earl Grey, and that's their solution for UI testing. We tried to make it work quite a bit, and to be honest, it could be better these days. Maybe we were misunderstanding something, but we couldn't get it to work reliably. A little bit, yes, but in a very flaky way that felt like it could just fall apart the next time something's updated. It wasn't reliable. It was very complex to set up and maintain. So in the end, we actually stuck with XC-Test. So we stuck with Apple's own UI testing library, which I've got to say is actually pretty good. It's reliable and it's pretty easy to write these UI tests. So we just stuck with Apple's default tooling, unlike with unit tests. So there are some big benefits that writing UI tests gives you. For example, you can automate going through core flows in your app, and that's one of the main reasons we want to do it. We thought we could save a lot of developers' time by automating testing these core flows from end to end. On top of that, during developing new features, we thought it'd be helpful to check that the UX behaves as expected, that the app continues to behave as we expect. When you tap this button, does it still go to the screen? When this happens, will the screen be dismissed? Just checking that all that is still always working. There are some big downsides to UI testing, though. It's sometimes pretty flaky. So UI tests will quite often just fail for no particular obvious reason, and then you just run the test again and it's fine. And running all these UI tests is pretty slow because you're actually launching the app, you're mimicking a user tapping buttons, swiping, scrolling, zooming in and out. So this kind of real-time app use speed. So a single UI test can take, most files take 1 or 2 minutes to run. So while UI tests are always going to be slow and they're always going to be a bit flaky, we did find there was one thing we could do to help with some of that flakiness and speed up the tests a bit, which is to bring in an new library called Succulent. It's quite underrated, not so popular Swift library, but it's very useful because it records and replays network requests for you as you run your UI tests. And this helps to remove some of the flakiness of UI tests because you're not performing real requests every time you run the UI tests, only the first time you run them. So it'll spin up a local server on your machine, your local machine, or on your CI machine, and will record the network requests and responses that the app's making on the first run, saves that into a trace file, and then on future runs of that UI test, it will get the responses to your requests from that trace file through this local server instead of going to your real backend. So let's jump into a demo now of our registration flow UI test, and then we'll look at the code behind it afterwards. So let's start with how we set up all of our UI tests in our setup function. First, we create our XUI application, and then we start setting up succulents. So first, we check for a trace URL. So we're checking if there's already a trace file that's been recorded for a particular UI test. So we're checking if requests and responses have already been stored for a UI test that you've already run. And if that's true, then we configure succulent with that trace URL so that it knows to not record real requests again, but just access the trace file to get us our responses. Otherwise, we set up Succulent to record new requests and responses to our record URL, which is the URL where the trace file will be stored. And we also give it a base URL. So we give it the real URL, which Succulent should perform requests to, because it's acting as an intermediary, as a local server on your own machine, on your CI machine. So we can start Succulent, and then before we launch the app, we set a launch argument UI testing. And this is so that in your code base, you can do a check for a launch argument, and we can check if UI testing exists as a launch argument. Then we do certain setup for UI tests, but this should be minimal. You shouldn't be interfering too much in your actual code base because you want to be testing, the real flow. You don't want to be mocking too much. But if you have to do some additional setup, which we do, then you can do that. And then we set the launch environment Succulent base URL to the URL of the local Succulent server, which is localhost, and then the port that Succulent gives us. So here's where we need our UI testing launch argument. It's so that we can reset the state of our app each time. So we set the user to nil to effectively log the user out, and we set skip login to false so that the login process is not skipped. And when we run our UI tests, we need to go through the login or registration flow. So basically, this is just something we need to do to kind of reset the app each time we run it. And then we need the Succulent base URL to tell our networking setup to use the Succulent URL instead of our real backend URL. Because now we run our UI tests, of course, we want all our requests and responses to go through Succulent so it can record or replay them. But only in the case that we're running our UI tests. Otherwise, when we run the app as normal, it will use our real backend URL. So this is an extra function we wrote for asserting that a certain element exists on screen as we expect. So we already have this wait for existence function, which you can call on any element, and you always have to pass the timeout. So you say, wait this many seconds to check that this element will exist on screen. We decided that it was a bit annoying writing usually the same timeout of 3 seconds every time we want to check the element exists. So we wrote this wrapper function with a default timeout of 3 seconds so that we can just call our assert exists function, pass in the elements we want to check the existence of, and then by default, that has a 3-second timeout, or we can pass in a different timeouts if we expect it's going to take longer for something to appear on screen. And then this is the example of the whole of our registration flow test. It's mostly a lot of tapping on fields, typing text, and checking that elements exist. So you can see we start with checking that a button with a particular ID can be tapped, and we tap it. And then we do the same for a few text fields. We tap them and then type in some strings. We do the same with the secure text fields, so the password field. And then we're tapping on some more buttons and just checking the elements that we expect to exist do, until eventually the whole registration flow has been gone through, and then we can open the menu and check that the user's been successfully logged in, ending with an XC assert true to check that the menu shows the logged in as string at the top. The easiest way to access specific elements is by giving them an accessibility identifier in your actual production codebase, and then that's the easiest way to refer to them in UI tests. And just add that as well as .tap, you can swipe, you can zoom, you can do all sorts of gestures and interactions on your elements. So a few top tips. Test only your core flows. Don't try and test every feature of your app. Test every single possible user journey. Just test the core flow of your app that you really can't have break every time you want to do release. The most important functionality should always work. Reset any cache data. Start with a clean base every time you want to run a UI test. So anything to do with being logged in or some state that was set when you've been running other tests, reset that every time. Avoid doing real network requests where possible. Of course, I'd recommend using Succulent. It's a great tool for that. But however you want to do it, try not to perform too many or any real requests to your backend. It'll only slow down your tests and it makes them less reliable. And then consider not running your tests on your CI on every single commit. Because they take so long to run, you might only want to do them, for example, when you merge into your master branch or before release, or maybe you want to do a nightly build to run your tests. But as you write more and more UI tests, it takes longer to run them all. You might not want to be running them every time you commit to a PR. So here are a bunch of links. If you want to check out the libraries I mentioned, Quick, Nimble, Cuckoo, or Succulent, here are the links. They're all worth checking out. I've written a couple of articles on units and UI tests on Medium, so you can check those out if you want. And you can ask me questions. I think you'll be able to now, but if you want to do that after the meetup as well, then you can always tweet me. And that's it. Thanks for listening.
app is not really convenient, because like sometimes it Hello, my name is Mikhail. I work in Blacklane as a senior software engineer. I actually work right now as a backend engineer. Just decided to switch from iOS to something different, to have maybe more experience just around different things. Right now I do stuff mostly in Go, and sometimes in TypeScript and in Python, but yeah, right now I just do mostly backend. But still, like, I did my fair share of iOS development, which was like 3 or 4 years. So yeah. So anyways, today I'm going to discuss about Redux, which is, I would say, just one of the interesting architectures out there, especially for the mobile. Before I get into technical details, I want to tell you a little story, like how did I made something in Redux. So it was like winter, Russia, and I just got offer from Blacklane, and but I didn't have like that many money on my savings account, and I wanted to have a little bit more before I move into Berlin, so I would be sure that, you know, the first months I live there, I have enough money. So I decided to help my friends with the app they wanted to do, and but the app was kind of, you know, like simple, and I decided, yeah, that's a little bit boring, and I don't want to really do boring stuff. So I decided to make my life a little bit harder, and I decided to approach a new architecture, and I tried to do this like in a way that would be like more meaningful for me. So I did this architecture, and today I will tell you about this app and like the architecture itself. So first, two things about the app. So the app is, what it does, it just scans NFC chips on some clothes, right? And then when you scan this chip, you get you get some info about the product, and the person can just look out like some cool videos, photos, and whatnot. So let's see a demo. So here we scan, I think, a pair of shoes, and you see like there is a cool info about there. Just a fun fact, I didn't use any libraries here, so I did everything myself, including this small loader. So yeah, I really decided to make my life a little bit harder. And I also, uh, maybe the hardest part there was to make this custom transition with a card. I had to modify the library in a way that it would be smoother and better anyways. So I did this app, and as you see, like this is the last page, which is history, and here I just do download the files from backend, and we have a lot of different scans, but of the same product, so it may look a little bit strange. Anyway, so the app has two screens on the tab bar, main screen and history screen. Both of them, they lead to a detail screen. And from the detail screen, you can go into photo gallery and you can go into video player. That's it. So not that hard. So what is like our plan today? We're first we'll discuss about what is Redux. We'll discuss like what main parts in Redux, like what are main entities and so on. Then we'll see like what specific parts in IIS are the most difficult one, and yeah, and the last one would be about advantages and disadvantages of the architecture for IIS. So the Redux diagram is kind of simple. We have a view which subscribes to the store to get events, and actually first it sends some events to the store. It sends some actions, for example, button taps, or I don't know, like screen transitions, any event basically which can happen on the view goes into store as an action. Inside we have the business logic called reducers. They get an action and they get current state of the app, and they return a new state, which then view subscribes and it listens for the new state, and then it updates itself. So we have this kind of unidirectional architecture. So first we'll discuss what is action. So action, it is the only way to interact with the store, right? So view can only send actions, and any other subscriber or any other entity can only send actions to the store, right? This is the only way we communicate. And this action can consist of arbitrary data, and it's is represented by classes or enum, structs or enums. You of course can use classes, but that doesn't make any sense. So just action is a protocol, and everything just empty protocol, so everything can conform to that. And then you can have, for example, this example of like scanning enabled action, which sends some parameters anyways. So the next thing is a state. And this is the only source of truth in the app. So you can have only one state in the app. And that means that actually everything is kind of synchronized. And the only way every view will get exactly the same state. So it's really important that important part of this architecture that you have the data synchronized across every app, every part of the app. And it usually, because we have only one state, it usually has a nested structure. For example, here we have like actually one substate per screen, and all of them, they form, the whole app state. So, and as an example, we have this screen state, which is a history list state, and it contains different entries for the table view, which we'll later display, right? So the state is immutable. We use structs there. So when a view receives the state, it cannot basically affect the state inside the store, right? So it only gets a copy, and that's very important because the state can be changed only inside the store. So it's kind of fully immutable. But you need to know that the copies of the state can be made really often. For example, every time your app updates, it changes the state, right? And for example, if some of the views are updates really fast, for example, I don't know, 10 times a second, then you would make copies of the state a lot of the time, and you will copy all the data, right? This is not really good. So in some complex cases, you need to make state copy and write. So then you will not be copying stuff unless it is changed. And again, we have one state for the app, just don't forget that, guys. Anyways, so then we have this thing called reducers, which is the main like business logic part of the app. As we discussed previously, they live inside the store, they get the action, they also get the current state and they return use state. So it's basically a function which takes two parameters, action and state, and returns state. Makes sense. So this is how it looks like in real life. So we have like this kind of action, and here it consists of different, like, let's say sub-reducers for each state, for each like sub-state, and then you have like you return when the action goes, it gets into this big reducer, and then it gets into, let's say, each of those sub-reducers, and then you get all the results and return this in a new state. Because like actually the action can be interesting not only for one specific like sub-reducer, but for many of them. For example, to one action, navigation reducer can react, and at the same time, maybe some other reducer can also react. For example, we have this history list reducer. It listens only for a specific action, and if our action is of specific type, then it kind of looks in the data of this action and changes the state accordingly. Okay, so reducers, again, they're pure functions. This is very important, they're synchronous, so you should not have any kind of complex calculations there, because like if you will have this calculation, they will block the whole app and the state will not be updated in this time, right? And there should be only the changes relating to the state. Again, like there should not be any asynchronous stuff. There should not be any other stuff, right? Just pure business logic, and it's better to be fast. So just like quickly, let's see how the view reacts to the changes. So again, it sends an action and it gets new state. So how exactly does it do? So it's, for example, in view will appear, it subscribes to something, and presumably in view will disappear and it can unsubscribe. And then here I just select, let's say, one of the substates, and then I define that I'm only interested in this current product state. And on the main queue, async, I update the view, because we actually should not rely on the queue on which the state is returned. We should always make sure that something updates on the main queue, right? Anyways, when we also interact with store, we do this like this. We just dispatch some kind of action. For example, here is just an enum, which we are saying the store that we want to expand the video player. So again, like what about asynchronous tasks? So we know that we cannot put them inside reducers because they're synchronous. They are synchronous, and yeah. So we also cannot put them inside view because views are dump and they are not for, you know, like request and other this kind of asynchronous logic. So we actually have specific component for that called middleware. And so what is middleware? Middleware is actually the guy that also lives in the store. As you see, like before we discussed that we have the action, we have reducers that change the state, but we also have middlewares that can also react to the action, but instead of changing the state, they actually send a new action. So what happens? For example, you have some, you know, let's say you load new screen and you want some middleware to go and get some data. And when the data is loaded, you also push new action, for example, data loaded action, which will then go to some reducers. So that's how middleware works. And just want to mention that you can have at the same time not only reducers reacting to action, but also middlewares reacting to actions. So for example, here, when we want to transition, to make history transition, you want to first go to like navigation reducer and understand like what exact transition you need to make. And second, you also want to fetch products on this particular screen, right? So, and that's how it happens, right? So we also, the middleware gets this action and it does some fetch, and then it sends a product fetch action. So that's how it looks like. So basically, we filter the actions that we don't need, but if we have the action that we really need, then we just do some stuff. For example, load product information, and then we send a new action, either product load completed or failed. So next we are approaching probably the most, the hardest topic, or the most complex topic, at least for me, in the Redux world. It's the navigation. And so why navigation is the, so first let's say like, what can we do about the navigation? So first we can think of leaving it outside the state. But I think that is like bad decision, because when you think about this, navigation state is also a really important thing, because like just looking, if you don't keep the navigation state, you don't know like on which screen you are, or which screen you are going to update, and you actually can miss some important information, and you cannot like make some decisions based on state without navigation. So I think the only real decision is to keep navigation inside state, but then you have to observe all native UIKit transitions to somehow reflect this in the state. And this can be kind of tricky, because like native UI components don't know anything about Redux, so you have to monitor every transition and know like how to reflect this in the state. So let's see our demo again. So we have mostly modal transitions, right? So this was the first one, this was the second one, then we go back. Then we go to, I think, another modal transition, right? This is Safari View Controller. Then we go back. This is basically stack transitions, right? And here is something different, right? When we go change tab bar, we actually, let's say, change the branch. And in my case, there were no view controllers on that branch, except for one, right? But actually inside this, there can be also some kind of complex navigation. So let's just look at the diagram. So we go, so first do modal transitions, then we go back, and then we do like, let's say, container controller transitions, or we just change the presented controller. Anyways, why is this important? Because we cannot model in the state, we cannot model our transitions just as a stack, because we can change this kind of branches, and this looks like more as a graph, because like imagine you can have 3 screens on one branch and 2 screens on the other, and you can immediately transition from one branch to the other one. So it looks like more as like a graph or a tree. You can think of a tab bar transitions as switching the branch, and you can think of a modal transitions as creating more levels in the tree, or yeah. So that's how navigation state looks like. In my case, it's just like a dictionary with branches. And the key is the name of a branch. So we have 2 screens. So basically there will be 2 elements. And then we have like a stack of transitions for each of the branch. So you need to keep track of all changes, and you need to mostly write custom components which will update your, your navigation state, and you should be ready to face difficulties and like find some solutions. For example, like this one, right? So I need to know, like, when I dismiss like my AV player view controller, so how can I do this? I need to actually subclass it, and or maybe I can do something else, but the idea is that I need to somewhere put this event that I dispatch close action. So I say that I go back from this screen to the previous one, so I should change my navigation state. So how I build the navigation? So first, like as we saw, view controller sends an action, and the action goes to navigation reducer. And here, for example, we have this navigation reducer, and it waits for different actions. Here, it's actually very large, but this is just a small part of it. Like we look at this photo gallery action, and if we want to open, like there is different types of photos we can open, but don't think about this. The main thing that we can open a photo, and then we should go to the photo gallery, and we can close the gallery, and then we should just remove last transition. So after that, we change the state, and there is actually a specific component which also subscribes to the state, which specifically handles the transitions. What it does, it actually tries to see if we already handled this transition, and if we did not handle this, so we notify all our observers. And so I have the specific entity called coordinator, which observes specific, let's say, transitions related to some views. For example, I have the current product coordinator, which is responsible for product details screen, and it is responsible for this kind of transitions from current product to video player, from current product to photo gallery, as we see that we just here present some view controller and so on. So it's not that hard actually, but like it's kind of convenient. So let's recap. We have screen composition reflected in the state. The transitions are instantiated via actions, right? In this like several, like in this several step structure, right? So we go through navigation reducer, then we go to transition handler, then we go to coordinator, and then we do transitions. Of course, you can simplify that, but just like I thought that it made more sense to do in this multi-step way. And you also need to observe specific UIKit transitions to make sure your everything is reflected in the state and it's always fresh. So then we have this notion of UI state. As I said, like we have only one state in the store, but sometimes we need to, let's say, also keep something like a view state, right? To assist you with some animations or to assist you with some other changes that you just want to do UI-wise, for example. And I think, so one of the examples is like, imagine you have a collection view and you have one state and you just loaded a bunch of, cells, and then you have the other state and you need to have a diff between two states to find out like which cells you need to animatedly, for example, hide or something like that. And you can do this by keeping a specific view state for this. And also, you basically need to transform, the models that are in the state into cell models, which would be most likely in your view. So you still need to have something like view state. So yeah, that's how it is. So, but these things we keep specifically for UI presentation, right? So we do this kind of state diffs and to update only the needed stuff. For example, in my app, I had this use case when the items were empty, I created new items, but when they were not empty, I knew that I did not want to update anything. And the only thing like I wanted to do, I maybe wanted to update like video player state and maybe update the main photo if it was downloaded. So yeah, that's it. So now I will talk about like the advantages of the architecture. So first advantage, like everything has a state. We have a clear and explicit logic, even though, you know, it can be very, you know, like it can be, you need to meticulously write every possible case basically in these reducers. So it can take a lot of code to write all that, but in the end you will not have any state that you don't expect. So that's very important. And that's very convenient. So your app will not be in an inconsistent state. It's also easy to broadcast application-wide events because like you can have many things just listening to the state, and if something you know, some views sends some action, you are sure that everybody will receive the updated state, and you don't have you basically have only one way of communication. That also makes a lot of stuff easier. Yeah, and state is always synchronized. You don't have any like inconsistencies in the app, which is also cool. And you may think that it's all very good, but there is still a lot of disadvantages. And first of all, and maybe I would say one of the main ones, is that navigation is pretty complex. You need to kind of handle all these navigation states, and the more complex your navigation gets, the more, you know, the more complex navigation logic you have to write there. So, and it can be tedious. So yeah, I think like one store per app or one state per app is not really convenient, because like sometimes it's get very big and you have to do this copy and writes if you have like frequent updates and so on. So it can be kind of hard. And I think like in the big apps, it can be kind of hard to maintain. And also it doesn't play well with CoreData and as fetch results controller, because like they have, you know, like let's say the state in itself, like the database, and you have to, you know, like somehow intertwine CoreData with the state. So I'm not sure that I feel that it would be kind of hard. I mean, like I didn't use this approach in the app where I had CoreData, but I would think that it will not be easy. And maybe some key takeaways from my talk. So you can actually, like when you do Redux, you understand that making like state-based screens and like having some state written in some parts of your app is really important, because even though you don't have to, you know, put everything as a state, but you can have like some main, you know, I forgot how to say it in English, but yeah, you can basically define your view logic very clear when you will say that it can be only like in these 4 states. Maybe even if you will not write all the data that the view can have at the time, if you just define the states, sometimes it can really simplify a lot. So I really recommend you to try to make states explicit when you're doing stuff with your views. So you can use this store-based thing only for the business logic. And in one app, for example, I use this approach just for keeping everything about the logic related to marketing banners. So I would know, for example, if I shown some banner on one screen, it will not be shown in the other screen. So I also had this kind of marketing actions, and then I had this kind of marketing stage and something like this. So because like we really had this very complex banner system, but anything else was outside the state, and it also worked kind of fine. And I would just recommend you to experiment with Redux-like architectures, because it's really fun, and I would say it's a little bit hard, but it's also kind of interesting, and maybe it can be cool to do this with SwiftUI, which is like declarative and so on. But I would be careful if you are planning to build a really big project, because like you will have like many difficulties, and there is a high chance of changing the architecture in the end. Because like at least with UIKit, it doesn't play really well sometimes, because UIKit is based on a little bit different principles. Anyways, thanks for listening. I hope you had some interesting time, or maybe at least you have more knowledge about Redux. And I am open to your questions. Thanks a lot.